So naming the angles, when you name an angle, you can name it multiple ways. You can name it with the vertex. You can name it with the 3 points on the side, and sometimes they put it as a number in the center. When you name an angle, you'll always put an angle symbol in front of it. So if I'm going to name it by the vertex is the point that goes in the corner. This is the vertex. I would name it angle A. I cannot call this angle B or angle C because you can only name an angle with one letter by its vertex. The vertex is the point that comes together, or where the two rays and come together. It's the point that they share. We could also call this angle BAC or angle CAB. Again, please take note that the center letter has to be the vertex. That's a requirement when naming the angle. The order of the letters is important. You can't just list them out any way you want because they're in there. You have to name the vertex as the center letter if you're using all three. So when they give you an angle, sometimes you'll have multiple things going on in a picture. The center letter will always be the vertex that you're looking at. Like I said, we could also put a number in here. Like maybe we'd pick a number, I don't care what number. Give me a 7, great. So we put a 7 in there, any number, it doesn't matter. Whatever number is in that picture, we could also call this angle 7. When you name it with a number, the number has to be inside. Sometimes it gets deceiving because they'll also put the angle measure inside. And a lot of times they forget to put the degree on it. So if you have an angle numbered 110, most likely that represents the degree. If you have angles numbered 1, 2, 3, like consecutively in a picture, then typically that'll be the angle number that you're talking about. So watch out for that. Sometimes it can be a little deceiving. Name the vertex. Remember, we just talked about this. The vertex is that center letter. The vertex is point A. The vertex is always a point. The sides are rays. Sometimes, however, your angle is not going to look like it's made up of rays, but by definition, the sides are rays, whether we see the arrows coming through it or not. So when we name the sides, I name the sides as rays. We have ray AB, A being the end point, also the vertex, and ray AC. Those are the two sides of our angles. So we just have to be a little careful, make sure that we are naming in the proper order. That's it when it comes to naming an angle. We'll also look at a few different types of angles. We have obtuse angles, acute angles, right angles, and straight angles. I'm going to draw a little picture of each and then also define it. Does anybody think they know what an obtuse angle is? Yes. Larger than 90 degrees, but it also has an end cap too. Greater than 90, but less than 180. So an obtuse angle is a wide angle an obtuse angle is greater than 90 degrees, but less than 180 degrees. Are you okay with these symbols? If you're not, make sure that you write that out as greater than or more than 90, but less than 180. I use a lot of symbols just to shorten it up. Math people can be lazy. We don't like to write a lot. That's why we don't write out the word plus. We use a plus sign, equal sign, all of that stuff. Okay, an acute angle, what's that one? Yep. Zero. Yep. So this one is greater than 0 degrees, but less than 90 degrees. That's the restriction on an acute angle. An acute angle is sort of a small little or less than 90 degrees. Then we have a right angle. What's our right angle? Exactly 90 degrees. So a right angle equals 90 degrees. And remember, we're not perfect. And even though I can try as I might to draw something that I think looks like a 90-degree angle, if somebody took a protractor and measured this, it could be 89 degrees or 91 degrees. So how do I tell the world that this is in fact 90 degrees? Put the little box in the corner. Don't forget to do that. Then there's no question. Then you can draw it any way you want to. As long as you put that little box in the corner, that tells the world it's 90 degrees. The last one is a straight angle. Can anyone take a stab in the dark? What do you think a straight angle is? Equals 180 degrees. It equals 180 degrees. And when we draw it, it actually looks like a line. It just looks like a straight, flat line. Now, it was, I thought, a good idea for me to put this picture of the protractor on there so we can kind of get practice reading it instead of handing out protractors, until I looked at the copies and realized, except for you can't read it. Sorry about that. So know that when you measure, each little tick mark, if you can kind of see those, is 10 degrees here, and we'll just approximate. It'll start at 0 and go up to 180 on the inside, and it'll start at 180 and go down to 0 on the outside. So if I could sort of fill this in, it's 0, 10, 20, 30, 40. You get the gist. And that'll go all the way down, straight up and down here is 90. And then on the other side, again on the outside, it's 180, 170, 160, 150. The two angles right above each other are what we call supplementary. And when you're measuring an angle, you have to decide which one you're going to be using. Just know that the angle will start on the flat line at 0. So if I start my angle over here, if I'm looking at ADB, angle ADB, then I'm going to be using the outside measure to measure that and count those tick marks. And again, I apologize for how bad this shows up. But this is a 0, a 10, 20, 30, 40, I believe that's what it is. 50, 60, 70, 80, 90, oh no. Nope, I'm 10, 20, 30, 40, 50, 80, 90. Those are on the outside. Okay, each little tick mark in there. So if I'm measuring angle FDE, FDE, can we approximate that? It's going to start at 0, and then the line that goes through F cuts through somewhere between 30 and 40, not between 150 and 140. And again, that's because I start at 0 when I measure, so I have to go on the inside one. 0, 10, 20, 30, 40. So I'm going to approximate that at about 35 degrees. These are just approximations, so do your best to approximate when you're looking at them. If I'm going to measure ADE, ADE, Now I'm going to start on the other side because A is down here, so I have to start at 0 on this side and follow it around. That means I'm going to use the outside measures. That makes it look like it's somewhere between 140 and 150. So we'd call that about 145 degrees, just approximating. When I'm measuring something that is starting not at 0, like ADE started at 0, FDE started at 0, the F came first. When I'm measuring something like CDF, look at the picture carefully. CDF, I'm going to grab so angle CDF is here. This is also angle FDC. F starts at 0. So I'll start on the 0 part. It starts on that line and count up. This one will go on the inside. That one looks like it's about what, if you could guess? Anybody have a guess on that one? Yeah. About 100 degrees. Beautiful. Angle BDA, another one. I'm going to erase this. And we do angle BDA, same thing. BDA is the same as ADB. A is the one that starts on 0, so that's the one that I'm going to count with. That looks like about, anybody got a guess? 25? Great. Now, what if I have one that neither end is at 0? Well, I'm going to erase my mark here and redraw that one. So BDF, I'm just going to count the tick marks that it's at. Did I do BDE? Oh, I'm sorry. Never mind then. Then I can start at 0 again. Start at 0 because this side is at 0. Let's approximate that. Where does it look like we are? 155? 65? 55? Let's count. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 1, 10, 20, 30, 40, 55. 155, yeah, we just have to count. Some of it, and again, that's because this is pretty crappy to look at, sorry. And our last one is BDC. And BDC was the one that I was thinking of, where we're going to have to just count our tick marks as best we can, or our measurement as best we can. BDC. Looks like BDC crosses at 80. I'll just start counting from there. 10, 20, 30, 40, 50, maybe 5. Does that make sense? So I'll call that one about 55 degrees. I could turn my protractor and do that. How many of you have used a protractor before? You kind of know how to use it. We're hardly ever going to use it again in here. I just wanted to show you again how to read it. So then we get into what we're really going to work on, and that's in our angle addition postulate. Just like the segment addition postulate, the sum of the parts equal the whole. So that means that if I have this point B that falls in the inside of this angle AXC, where X is the vertex, then this little m stands for the measure. The measure of angle AXB plus the measure of angle BXC equals the measure of angle AXC. So the sum of the parts equals the whole. So just for instance, if I put a 30 degree here and a 50 degree here, what's the measure of angle AXC? 80 degrees. because the sum of the pieces equals the whole. That's all that that's getting at. We can also have an angle bisector. And when we talk about a bisector cuts things in half. It cuts things at their exact midpoint. So this bisector cuts an angle in half, exactly in half, to make two congruent smaller angles. So I'm going to draw a little or sketch a little picture on the side here. We'll label this. I need four letters. Yep. Anybody? A, B, C, D. Excellent. So ray BD bisects angle ABC. Ray BD bisects angle ABC in my picture. And if that is true, then the measure of angle ABD is equal to the measure of angle CBD. That little m again represent measures. That means their measures are the same. And we show that with congruent marks in the picture. If they're congruent angles, they'll have a little angle mark that matches in each picture. So this tells me, because both of these have one little swoop on them, this tells me that ABD is the same measure as angle CBD. And that's the case because BD bisected angle ABC. Now I could put a second little swoop mark in there as well, but if they're congruent, then they'll both have two little swoop marks. Does that make sense? So if I had a picture where I had one swoop mark and two swoop marks, those are not congruent angles because they don't have the matching number of swoop marks. Okay? And I'm pretty sure swoop mark is the technical term. Okay. Let's do some math. This is what we are all here for, right? This is our favorite part of the day, doing some math. Yay. Okay. So here we have our picture. This is the same picture that we're going to use for all of these, or for most of these, I believe. It's all angle ADC with B in the middle. All right? So I'm going to redraw it each time. And in fact, what I'm going to do is I'm going to get a better piece of paper so that it doesn't have all the stuff showing through. So we have a clean sheet of paper so my marker doesn't leak through. All right. So here we go. Let's set up our math. Again, we're going to be using the same picture over and over again. And this tells me that the measure of angle ADC is 5x minus 20. So ADC, this is how I mark it. I'll put this big line here, and I'll mark that as 5x minus 20. And then it says ADB. ADB, this little piece right here, is x minus 4. So I'll sneak that in here, x minus 4. That's the little piece. So the big angle was 5x minus 20. This little piece is x minus 4. Then it tells me that the measure of BDC is x plus 5. So I'll put x plus 5 here. The sum of the parts equals the whole. Let's do some algebra. Who can set up my equation? Beautiful. The sum of the parts, that means if I add together the two pieces, I get the whole. Now my job is to find x and ADC. So let's start by solving x. What do I do first? Yep.
Add all the like terms together.
Yep, combine the like terms. So I get x plus x, 2x, minus 4, plus 5, plus 1. When I'm adding like terms, remember back in your algebra days, you can only do that on separate sides. There are two sides of the equation that are separated from each other. So I have a left-hand side of my equation, a right-hand side. I simplify the left-hand side, I simplify the right-hand side. Once they're both in simplified form, then and only then do I solve. And so now I'm going to solve. Any suggestions on how to do that? Go ahead, Jonathan. Subtract 1 from both sides, fine. I don't usually subtract the number first. Usually I subtract the x's first, but you're right. That is, everybody kind of maths a little bit differently, and so that'll get what I need done. So this is 2x equals 5x minus 21. I have to bring that over here. 2x equals 5x minus 21. What's my next move? Yep. Minus the 5x, great. So negative 3x equals negative 21. Getting closer. What's my next move? Divide by negative 3. So x equals 7. I can put that in the x category there. How do I find the measure of ADC? Yep, I go right back up, pick the one that I'm looking for. They said find ADC, so here's ADC. That's the one I'm going to use. So I will do 5x minus 20. I would do 5 times 7 minus 20. 35 minus 20, or 15. That means that's 15 degrees. Did I do okay, math? Do we agree? Everything looks all right? Okay. Does this look like a 15-degree angle? No. Do we care? No. That doesn't matter. If they tell us this is what the values are, that's what the values are, no matter what. What's that? It might just be zoomed in, right? Or looking at it at a funky angle. Who knows? All right, so here we go. Let's set up another one. Before we begin, I'm going to draw the same picture. I always call this a dummy picture. I hope nobody's offended by that. It's just a picture that can hold the pieces. And because we're going to be using this picture for all of them, I'm going to use the same letters. This was A, D, C with B in between, and I start filling stuff in. ADC, the big thing here is 116 degrees. ADB is X. What is this? BDC is 3 times bigger than ADB. Yep.
3x.
Beautiful. 3x. The sum of the parts equals the whole. What does my problem look like?
3x plus x.
Perfect. How do I solve? What do I get on the left? 4x. Finish off by, I think I heard a 29. Anybody agree? Anybody want to fight that one? So 29 goes here. I have to find the measure of angle BDC. I'm interested in finding the measure of angle BDC. That's this guy right here. Yep. So we'll put in 3x is what I'm solving for. 3 times 29. I think you said 87. And that's a measure, so we'll go degrees. Now we're going to get into some bisector problems. So same picture, but this time the ray bisects the angle. So I'm going to draw the same picture. A, D, C with B in the center. Ray DB bisects the angle. That means that these two angles are congruent. So I'll mark that in there. Congruent angles, even if they don't look like they measure the same thing, the information that they told me makes me believe that they do because it says bisects. Bisects means it cuts it in half. That means that's going to go right down the middle. That means both the angles are going to be the same. So if the measure of angle ADB is 4x plus 20, and BDC is 5x plus 15, what kind of equation can I set up with that? I forgot my plus. 4x plus 20 equals 5x plus 15. If they're congruent, that means their measures are the same. If their measures are the same, I can set them equal to each other. And when I set them equal to each other, that gives me an equation to solve. What's my first move in solving? Okay. Perfect. That leaves me with 20 equal to 1x plus 15. Remember, when you have 1, you don't need to write it. How do I finish this off? Is our algebra coming back to us a little bit? Yeah, okay. X is 5. Now I need ADC. ADC. So I'm going to use that different color here. That's this whole thing. Everybody's mind works a little differently. There's more than one way to do this. What's a way? Okay. Okay. Do both of them, or just one of them, or which one? Just one of them, and then do what? Right. So if I pick 2 times 4x plus 20 to find the measure of angle, that's double this size. That would be 2 times 4 times 5 plus 20, or 2 times 20 plus 20, or 2 times 40, or 80 degrees. That's one way to do it. Another way you could do that would be to plug it in for both of them and add them together. So it would be 4x plus 20 plus 5x plus 15. That gives me 4 times 5 plus 20 plus 5 times 5 plus 15. Either way, I get the same answer. Pick the way that works for you. There's not one way better than the other way. Again, this is just a big fat or between these two. You don't have to do both of them. Okay, pick the one that works. All right, I'm going to draw that picture again. Got 2 more examples we're going to do, and then I'm going to let you ride on your own. So I'm going to draw that picture one more time. Put my letters in the appropriate spot. Once I get my picture drawn, then I'll start filling in the information. Ray DB bisects again, great. If it bisects, that means these 2 angles are congruent, so I'll mark them as congruent. Put the little congruent markers in there so I know. That way if I get a text or something and I get distracted and I come back later, I already know these are congruent. I don't have to think about it or start all over again. The measure of angle ADC is 10x minus 38. That's this full angle. Notice how I marked it with 2 lines. Because if I mark it with 1, then we would assume it's the same measure as those other 2. So I'm marking it with 2 lines to make it different. That whole angle, ADC is 10x minus 38. And BDC is, squeeze it in here, 3x plus 1. Okay, now what? I've got the full, I've got a piece. What else do I know? Yep. Yeah, these 2 are the same measure. That's what the bisect mean. That's why I marked them, so I can put the 3x plus 1 there as well. So when I set up my equation, I can write it as 3x plus 1 plus 3x plus 1. Sum of the parts equals the whole. Or I've also seen people write it as 2 times the quantity 3x plus 1. Again, these 2 things are equivalent. They mean the same thing. One is not better than the other. It's personal preference. It's how you math. It's how you were taught. Whichever way you do it, your first move is to simplify whatever you can. So I can get 6x plus 2 equals 10x minus 38, and then I solve. This is how I solve. Minus 6x, leaving me with 2 equals 4x minus 38. So I distributed the 2 here to get the 6x plus 2. Then I started to solve by removing the 6x. My next move would be add 38. I get 40 equals 4x. Ran out of room. And then finish solving by dividing. Measure of angle ADB is the one I need to figure out. So good thing I marked that. ADB, that's this guy right here, 3x plus 1. So I'll do 3 times 10 plus 1. .31 degrees. Our very last one. Same picture. Let's squeeze that picture in down here. A, D, C is the outer ray. It says ray DA, and ray DC are perpendicular. What the heck does that mean? They create a 90-degree angle, whether it looks like it or not, right? That's a 90-degree angle, so I put that little square box in there. That's supposed to be a square box. 90-degree angle. Then it says dB by sec, so that also means these angles are congruent. And that's all it tells me.
ADB is 45.
ADB is 45 degrees. BDC is 45 degrees. ADC, we already said, forms a right angle, so it's 90 degrees. Remember, if it bisects, it cuts it in half. So we just have to take that 90 degrees and divide it by 2. That'll get our other two angles. So your job is going to be to practice some of these problems. On your worksheet, your protractor is much nicer. How do you get this one? Because they told us that it's perpendicular. Perpendicular means it's going to be a right angle, so that's how we did it when it was 90. And because this bisects, that means it cuts it in half. So we just have to cut the 90 in half to get the other two. Does that make sense? Yeah. Of course you can. Yeah. They're buried a little bit above yourself. Right on by my desk, by my computer. Let's see, we have class today until 10:28. I am going to assign all today. So 1 through 24, that's your homework. You have the remainder of class to work on it. If you have any questions, I'm here for you. Don't hesitate to ask. Feel free to work with somebody if you would like. If you are not understanding something, just let me know. For the first few, you're approximating the angle measure. The next few are deciding acute right straight. Naming and then doing some math on the back.
So how do we get the ones that aren't by the 0?
So it's going to be easier to see on this
Okay.
sheet, sorry. Okay, so if you, which one are you looking at in particular? So MLN, so MLP. So what I do is I just make this like 0. So I'll pick one to start at, it doesn't matter which one. And then I just count 10, 20, 30, 40, 50, 60. Good? So I usually start, I pretend this is 0 and then this is 10. No, so like in our naming the angle, you can either name it by the vertex or the letters or the number. Good?
that class going?
Not too bad.
Okay, is that what you're working on now, or are you?
Yeah.
Okay, so let's mark that here. FXH has 130 degrees. So make sure that's not FXH, and so. So what I usually do is if it's a big angle that crosses, I don't want to put one tick mark, but this one is 130 degrees. Okay, that marks this whole thing. Okay? And what else is this? FXG is 49. So what does that mean? Great. This one's congruent to that one, so what does that make this one? Great. And then, because together these are 130, what does this one have to be? How could you figure it out? It's subtraction, yeah. 130 minus 49. I know. Oops, and you have 130. And then see what you can do. See if you can fill in the missing parts. Yes. So FX3. Oh no, this asks FX3 is congruent to what other end? What other end is this in? Perfect. And then see if you can get so JKL and CBR converged, and JKL is 137, and you have to get that seems easy. Okay. Yes. No? That's congruent to, yep, exactly. Yep, that has the same measure. 3S. Yep, and 8S. That's the, instead of X, that's the variable.
Okay.
Yeah. You don't always have to use X, but I generally, personally do. I don't know. So the whole thing is 130. What are these marks mean? That those are congruent. So this is asking you what angle is congruent to FXG. Which, how would you name the angle that's congruent? WYX, that looks sure. And ZYW, that looks perfect. And perfect, yeah, because they're congruent, so they're the same. So knowing that they're congruent, you also know that this one's how the. Okay, so measure of GXH. So now I have to figure out this one. So if this whole thing is 130, then this piece is 49. How can I figure out this little piece? Minus? So 130 minus 49. So name the straight angle and figure which angle is a straight line. And there's more than one. No, which angle would totally fall on a straight line? So it's 3 points that are basically cones. And which other one? And is that in the same, there you go, yeah, I is the one, yeah. So we'll call that angle FXL. Perfect. There you go. And then the rest of this stands for another stuff. So, this is 3S and 3S, and you just read X and that's really fine. What are the measures of RZS and TSC? So RZS, so they want to figure out what this measure is and what this measure is. So we found what X is, right? So what does this one have for you? Right. Perfect. That's exactly what I